Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will see how we can perform simple thresholding on images using OpenCV. So first of all, what is thresholding? So thresholding is a very popular segmentation technique used for separating an object from its background. The process of thresholding involves comparing each pixel of an image with a predefined threshold value. And this type of comparison of each pixel of an image to a threshold value divides all the pixels of the input image into two groups. So the first group involves pixels having intensity value lower than the threshold value, and the second group involves the pixels having intensity value greater than the threshold value. And using the different thresholding techniques which are available in OpenCV, we can give different values to these pixels which are higher than the threshold value and which have the intensity lower than the threshold value. So let's see how we can use simple thresholding techniques on an image. So to start with, I have this simple code which loads an image on a window, and this image is called gradient.png. So let me show you how this image looks like. So this image looks like this. So as you can see in this image, we have on the left hand side the black values, and when we gradually move from left to right, we move towards the white value. So on the left hand side, the pixel value are closer to 0, and on the right hand side, the pixel values are closer to 255. So now we are going to just involve some thresholding techniques, and we will see how this image is affected by the thresholding techniques. So first of all, what we are going to do is we are going to define two variables. One is underscore, because the result of the thresholding gives two results. One is RET value and the second is the thresholded value of an image. So I'm going to just say the second value which is given by the thresholding technique is th1 is equal to cv dot threshold, and this threshold method takes several values. The first is the source, so our source is image. The second is the threshold value. So as we have seen that our image have on the left hand side 0 pixel value, and when we move towards the right, its pixel value increases to 255, right? So let's say our threshold here is 127, and the maximum value of the threshold is 255, which is the white color on the right hand side. And then the fourth value here will be the threshold type. So there are several threshold type in simple thresholding. We are going to see them one by one. So the first thresholding type is cv2 dot thresh binary. So first of all, let me show you how the result looks like, and then I will explain what does this thresh binary type does. So what we are going to do is we are going to use one more cv2.imShow method to show this thresholded value into a new window. So we are going to just show this value into a new window, and we already have the original image in the image window. So let's run this code and let's see what happens. So you can see in this binary thresholding, we are comparing each and every pixel of this original image to 127. And if the value of the pixel is less than 127, the value is assigned to 0. And if the value of the pixel is greater than 127, the pixel value is assigned 255, that means white. So if the value of the pixel is 0, it will look black, and if the value of the pixel is 255, it will look white. So this is how binary thresholding works, and by the name itself you can understand that this is just a binary thresholding. So it's either 0 or 1. Now let's see the other type of thresholding technique. So now I will just change the name of this variable as th2, and the next type of thresholding is called thresholding binary inverse. And as the name suggests, the thresholding binary inverse is going to give the inverse result of what you get from the thresh binary. So I'm going to once again use the IamShow method to show the result of this thresholding binary inverse value, and let's run the code and let's see what happens. So this is the original image, and then we have the thresholding 1 image and the thresholding inverse image. So this image you got from the first thresholding, which is by using thresh binary, and the second image you got from this method, which is thresh binary inverse. And this thresh binary inverse image is just the inverse of what you get using the thresh binary. So if the pixel value is lower than 127, which is our threshold, the pixel is assigned 255. Otherwise, if the value is greater than 127, then the pixel value is assigned 0, which is the inverse of what we got in the previous step. Now let's change this threshold to, let's say, 50, and here also let's say we change this threshold to 200, and let's see how this result changes when we change the threshold value. So I'm going to run this code once again, and you can see this is the result of thresh binary. And now because our threshold is up to 50, that's why our result is like this. So until the pixel value is 50, it's black. Otherwise, if the pixel value is greater than 50, it's going to give you the white pixel value, and the thresh binary inverse is going to give you the inverse value of what you get in the thresh binary step. So I'm going to once again just close these windows, and let's see the next thresholding type. So I'm going to name my variable as th3. So the next thresholding type is called thresh trunk. So this is this type, and let's first of all see what is the result of this thresholding technique, and then I'm going to explain what it does. So we are going to just show this thresholded image into a new window and run the code, and now we have the result. So let's move it like this, and we have here the original image, and the result of the thresh trunk is this th3. So here what happens is, up to the threshold, the value of the pixels will not be changed. So up to 200, because our threshold is up to 200, so when the pixel value is up to 200, the pixel value will not change, and after the threshold, which is 200, the pixel value will remain the same, which is 200. So from here to here, the pixel value will remain 200. Let's change this threshold to some other value, let's say 127, and then let's run this code, and you will see that now from black to 127 pixel value, the value of this image will not change. So original image up to half is the same, and after the pixel value 127, the value remains 127. Okay, so the pixel intensity value will remain 127 until the end. So if the value is greater than 127, the value will remain 127, and if the pixel value is lesser than 127, then the pixel value will remain unchanged. So this is how the trash trunk works. And let's see the other method, which is, let's say, th4, and this is the method which is called trash to 0. So we are going to just use trash to 0, and then we are going to open this th4 into a new window, and let's run this code and let's see what happens. So now we have this result. Let's move this to the left, and the result of the thresh to 0 is this one. So in thresh to 0 thresholding, whenever your pixel value is lesser than threshold, the value assigned to pixel will be 0. Okay, so when the pixel value is lesser than the threshold, the pixel value is assigned to 0. That's why you can see half of the image is black. And when the pixel value is greater than 127, which is our threshold value, the image or pixel value will remain the same. So after 127, all the pixels will remain the same. Let's see the other technique, which is called thresh to 0 inverse, which you already understood, I think, what it does. So this is thresh to 0 inverse, and we can just change this variable name to th5, and here we can just open it into a new window, and I'm going to run this code once again. Let me move this here and the result here. So you can see this thresh to 0 inverse is just the opposite of the thresh to 0. So if the value of the pixel is greater than the threshold value, which is 127, the value will be assigned to 0. Otherwise, if the value of the pixel is lesser than threshold, the value of the pixel will remain the same. So this is how some of the simple thresholding techniques works in OpenCV. We will see other thresholding techniques in the later videos. So stay tuned, and I will see you in the next video.